So just this little presentation is 25 minutes. I just want to really just stimulate your brain into thinking about troubleshooting of SCADA and data acquisition systems, probably a little bit of a refresher for some of you, and others something new maybe. We're on the internet here. I'm actually normally in Perth, Western Australia, but I'm actually in Cape Town today, meeting with various students and people here. So it's really good to be down here. The presentation is fairly full of lots of information, and as I said, it gives you a quick introduction to SCADA, and then we'll go into some of the issues which I just want to highlight with troubleshooting. So I'm going to ask you guys questions. Willem, Rangari, Salim, although Salim can't hear us at the moment. So, I mean, Carol, maybe you can just tell Salim to log in and log out again, but I suspect he's probably got the wrong version of the browser or something else. So just briefly, I want to go through a quick background to SCADA, which I think most of you are familiar with, so I'll do that quickly. Simple SCADA and data acquisition system, and then some of the communication structures, and then troubleshooting techniques. So just a little quick whirlwind trip. And we present these courses all the time. There's a possibility that you'll drop out. Well, I'll drop out because of the wonderful internet. Who knows what's around the corner? But as I said, just log back in again, and we'll catch up. And worst case, you can't log back in because you can't get on anymore. Just bear in mind, we'll send you a recording. There's about 70 or 80 guys that have registered, and most of them just take the recording. So just quick background to SCADA for those of you not familiar. Supervisory Control and Data Acquisition System. The word SCADA often is used for two different sort of systems. One is a system in a factory where you connect it to PLCs or RTUs, these RTUs here, with sensors, and then you connect through a field bus, Ethernet, RS485 to a PC, and that's sort of factory control. So that's the one aspect of SCADA. The other traditional version of SCADA is, I won't worry about that, is this sort of thing here. And you may use SCADA for description of either or those. So here we've got a sort of water utility type application where you've got remote RTUs, remote terminal units scattered around, and you're connecting through to some sort of, through radio to a modem, and then you connect it onto the display unit. I put RS232 in there because, unbelievably enough, there's still a lot of RS232, but hopefully today you'll be using Ethernet or at least RS485, and I'll look at those issues in a tick. So that's the other version of the SCADA system. There's one, and then there's the other one, as it were, if I can quote from Blackadder. So local area networks, you're all familiar with. Industrial Ethernet is the name of the game today. Can anyone tell me what the typical speed of industrial Ethernet is today? Any takers there? What sort of speed are you looking at? Just text it in the box there. What is the speed of industrial Ethernet today? Just text in the box. No? Any suggestions? Well, they started off with 10 megabits per second, but you've got a minimum speed today of 100 megabits per second, or probably a gigabit at least. And can anyone tell me what sort of connection they use for industrial Ethernet today? What sort of cabling? Yeah, thank you very much, Rangarai Koga. 100 megabits per second is probably a typical speed today, and a lot of systems are 1 gigabit or higher. And what sort of cabling are we using for industrial Ethernet? Can anyone tell me, to be on the safest? Any just text in the box? No idea. Okay. Typically, you can still use copper twisted pair, but you can only run it over a short distance, typically 100 meters. So honestly, if you want to be safe on an industrial site, don't pussyfoot around. Always go for fiber. That's the name of the game. Yeah, as Rangarai Koga says, Cat5 UTP, untwisted pair, you can use, but honestly, if you're working with an industrial system, just go for fiber where you can. People avoid fiber because they say it's a hassle, but I'll come back to that in a tick. So typical SCADA system software, here's a typical SCADA system here. Again, this is often RS485, or don't worry about RS232, and you typically got a database sitting on your system here, gathering information from your remote terminal units over here over a radio network, typically using UHF, ultra high frequency, and then distributing the information to your SCADA nodes over here, display nodes here. And in fact, today you'll often find that these are just little PDAs or mobile phones where you actually look at the activity. And that's one of the biggest challenges today. In fact, if I had a time, what we would do is spend most of our discussion today on cybersecurity. Hacking is one of the biggest problems today. And I think we're going to get some nasty attacks in the future because the systems are so open. So the SCADA system has typical features like this. And again, I think most of you may be familiar with them, but typically what you see most of the time is graphics displays, alarms, trends. You have an interface to your RTU, remote terminal unit, or PLC. It's got to be scalable. That's often a big challenge for a lot of SCADA systems. Now you put in for 1,000 points, analog and digital points, and all of a sudden you need to go to 1,500. Is your system scalable? So those are all issues when you're designing. Networking, fault tolerance, and redundancy. In other words, if something goes wrong, how do you handle the failure? Often we always think of failure with software and stuff like that, or a PC failing. Often it's a communication channel, and again I'll come back to that. So it's really important to think about redundancy, and in fact redundancy also goes into your RTU area. For example, people always forget that when you're gathering data, you may be gathering critical digital analog signals, and you've got everything set up for multiple redundancy and everything's going well. You suddenly forget that you need to also make sure your power supplies to those I/O racks, input-output racks, are also redundant. People often forget about those critical things. So I'll come back to that in a tick. So typical SCADA package, often produced by a single company. There's often a lot of open packages today, which make things very interesting. Welcome, Faraya. Perhaps, Carol, you could just text in the box, can you hear us? Because he may not be able to hear. And Carol, can I ask you, can you hear me okay? Or is it blah, 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 blah?
I can.
Thanks very much, Carol. Carol's poised to go on a long holiday, so she's probably thinking of beaches in the Pacific, some little atoll, and lying there enjoying a little gin and tonic while the sun's setting. Anyway, let's pursue this. So client server system for SCADA systems is a typical example where you've got a client server system. Can you tell me what a client server system is? Any comments? Just put in a text box there, a client server system. Rangarai Koda? No? Okay, client server system is, example is in this diagram here. And what you'll see is that these guys here we have a I/O database here where we keep all the information of what's going on in the field. So this information is all gathered, and the idea is that the I/O database is the server, and then these guys here, the individual nodes, they can gather information from their server. So they're clients. So it's a client-server network. Very important thing. So the idea is that you have a central database and you extract information. Here's another example of a SCADA system, perhaps a little bit contrived, but nevertheless you'll see the PLCs here, RTUs, and then of course server here with all the information, and then all the individual clients gathering information from the server. So again, I think we've got a pretty good idea of what a SCADA system is by now, data acquisition. So just another comment also about the topics of communications. The other important part of the SCADA system is not only the software and the hardware, which I've sketched out, but I just want to mention the actual communication channels are really, really important. And this consists of the hardware and, of course, the software. And I'm sure that most of you guys are familiar with the OSI model. I'll just sketch it there, where you have the bottom layer, you have various layers to your communications. So at the bottom layer, you have the physical layer. Then you have the data link layer, network layer, all the way up. So the idea is that everything is structured in a nice, orderly way. The Modbus protocol typically resides in the application layer. And the DMP protocol also is up at the upper levels there. So the idea is that you have a very structured approach when you're designing a communication system. So I'm not going to worry too much about the 232 interface, because hopefully you do not come across that, to be avoided, because it is actually very susceptible to noise, and it's pretty well non-existent these days. No one in his right mind uses it. Unfortunately, there's a lot of legacy systems with 232, and only last week one of the engineers was complaining to me he had to troubleshoot a 232 link. One of the wires had broken. He wasn't quite sure what was going on, but he troubleshooted because it's actually part of a legacy system from about 15 years ago. So you still get these systems, but hopefully, as I say, to be avoided. They're very slow, and of course they have a big problem with noise getting in very easily. So the system that you typically see today with SCADA systems is either RS-485 or Ethernet, industrial Ethernet, hopefully. And industrial Ethernet, I'll come back to in a tick, it's got to be industrial in the real sense of the word. So if you compromise with a nice commercial industrial Ethernet system, which is actually consists of sort of RJ45 connectors and very flimsy cable, you've got an issue. So the 485 standard is the, should we say, the workhorse of most SCADA systems today, especially at the field level. And you can go up to distance of 1,200 meters, speeds of 10 megabits per second, and you can have 32 RTUs on the system. The biggest challenge with 485 is that its speed isn't unlimited like Ethernet is. But one of the challenges where people always make a mistake with 485 is that it's extraordinarily resistant to noise because it is a balanced system. And balanced basically means that every one of these guys over here, these receivers here, actually look at the differential voltage. They look at the voltage across the lines there. And as you can see, the earth is down here, the ground, and of course, no problems here. So with earthing issues that you have with RS-232. So 485 is very resilient to noise and interference. So it's a great system to use. Only thing is, often people forget or they break off is that you need termination resistors at the end of the line, because if you're sending a pulse down a line like this, if it doesn't have a termination resistance because it's broken off or someone has forgotten to put it in, you will find that you get reflections back, which you obviously don't want. So very important. And that, I'll remind you from your wonderful days of university or college when you did transmission line theory, that's where it comes from. One of the biggest challenges with 485, in my opinion, is not so much noise and interference. It's very resilient to that, as I said. But the biggest challenge is what we call common mode voltage issues. And that means that if your receiver floats up for whatever reason in voltage with reference to ground, you will have a common mode voltage drop out. You'll have the receiver dropping out or indeed failing. That's something to watch out for. So you make sure that your grounding philosophy is always very good. And if you do not do that, you will have a potential issue with 485. Here's a 4-wire network, a little bit complicated, but again, the diagram is quite simple in the sense that you're transmitting down here and receiving there, and you've got your slave devices here. And probably the most famous protocol used for this is, of course, Modbus. And again, as I said, important that you have grounding to ensure that you don't have any common mode voltage issues. And again, that means that you've got, with this system, you've got 2 wires for every signal, and then you've got a 5th wire here for your ground. That's really important that that's done properly. If you neglect that, you will get dropouts. Another issue with 485, which people often neglect, is often there's a need to put in bias resistors to avoid the issues with common mode voltage problems. Again, very helpful. So Modbus is the other protocol used. I just want to mention there's 2 protocols here, DMP3 and Modbus. I'm sure most of you guys have come across Modbus at some time or other. It is a protocol which absolutely bewilders me that it's still around. It's been around since the 70s, 1970. That's almost 40, 50 years ago, and it's still around today. People are still using it. Now, Modbus in the old days used to just be used over RS-485, but often you'll find it used on top of TCP/IP stack. So you have the Ethernet. So you remember that OSI model I was talking about? You often find Modbus sitting on top of a protocol stack. So basically, you'll find that you've got Ethernet at the bottom here, these 2 layers here, the physical and the data link layer. Then you've got the IP protocol sitting here. And then you've got the TCP protocol sitting here. And it's beyond the scope of this presentation to talk about what they are. And then on top of it, you've got Modbus. Quite bizarre. But Modbus is still, as I say, used today, and it's very important that you understand how it works. And often there are issues with troubleshooting of Modbus because you've got a very simple structure with Modbus. It's got an address field, where you're sending the message to, the function field, which is read or write analog or digital. So you have a particular function number. And then the data field is the data you're sending or the data you're receiving. And the error check field is a very simple CRC 16. The problem with Modbus is when you're troubleshooting it, if there's an error due to noise, the Modbus slave does not respond, just ignores the message. So the message has to be perfect, otherwise it will not respond. So if there's noise on the link, you may find that you see no response coming back. And it's very easy to troubleshoot Modbus today with a protocol analyzer, which can be a simple PC just interfacing there using one of the protocol analyzers like Wireshark, which are free. You can download it from the internet. So if you haven't got a protocol analyzer on your PC from Wireshark, get it today if you're working with SCADA systems. So this is just an example of a Modbus master-slave network. As I said, it's bizarre that we still have this protocol around today, but as you can see, it's reading 4 different quantities, analog inputs, analog outputs, digital inputs, digital outputs, and these are all saved in 16-bit input registers or 16-bit output registers, so you can drive from here using Modbus. So Modbus, as I said, the problem is if you don't get a response, it may be due to errors in the link, noise, or, as happened to me, the guy who's the software that's creating the CRC calculation hasn't done the right thing, but that's unlikely. So 2 types of messages, query response. The other protocol is DMP3, which is used, and again,
It looks like Steve's connection has dropped out, so if you can just bear with us, and hopefully he'll be back in the room very quickly. There we go. I think your connection dropped. I can't hear you, Steve, so hopefully your connection will...
Sorry, Carol. Yeah, sorry, everyone. I dropped out. I touched the... I swiped my finger across the screen and then it dropped out. I'm sorry about that. Very much apologize. Hope you can hear me now.
Yes, you're back with us now, Steve.
Yeah, stupid. It's too easy these days. I just was trying to slide my finger across the DMP3. So the other protocol beside Modbus is DMP3, which is very much used. Can anyone tell me here, have they used Modbus or DMP3 for their SCADA systems? Please let me know in the box. Has anyone used Modbus or DMP3? No one. Okay. You would come across Modbus. That's probably the most popular protocol even today. As I said, it's amazing that you can still have this, but it's still around. But DMP3 is used for the classical SCADA system, where you have SCADA with water utilities or electrical utilities over long distances. DMP3 is very popular for that. There's also another competing one called 60870, which is not used much. So DMP3, very much designed for SCADA systems. You will not find it used in a factory or a plant, but you will find it used over distance links, such as, say, a water utility where you've got boreholes, treatment water plants scattered over hundreds, maybe even thousands of kilometers. It's an open protocol, which, like Modbus, which means anyone can use it. So it's a great protocol to use. And it's a lot more sophisticated than Modbus. There's timestamp messages. There's a whole list of features here. But basically, it's a very sophisticated protocol, and it's ideal for a water utility or electrical utility. It's not used for as I say, for a factory or a plant. You'll probably see Modbus used there. So here's a typical example of where the DMP3 would be used. So just have a look now. I just want to look at the hardware issues with troubleshooting SCADA and data acquisition systems. Just want to talk about some of the issues here. So one of the things here is that, as I said, you've got all this hardware, and we tend to often neglect the issues there with hardware, and we tend to neglect a lot of the issues with the power supplies. Very important to actually, obviously, do not remove components while the system is powered up. You don't know what the design has done, but I've seen people often just pulling out PLC racks or RTU racks, pulling out the I/O modules while the system's online, powered up. Very risky behavior, so don't avoid that. And the other thing is, obviously, if you're working with an antenna system, make sure that the antenna system is not disconnected from the system unless a dummy load has been installed. Otherwise, the radio power amplifier may be installed. Now, most systems today have ways to protect, but again, you can't trust. There's a lot of legacy systems around. So be wary of those. If I can just go back. So one of the challenges, obviously, is a few problems which can be examined. One of the challenges is you could have a failure of your system with your operator terminal locking up intermittently. And as I said, one of the challenges there is, what do we do? I can promise you often that is due to the fact that you've got noise or some spike coming into your communication system. And the important thing always, if you can, is use fiber. Fiber, fiber, fiber will get you around a lot of problems. The great thing about fiber instead of copper for your connection means that you actually avoid noise interference because you can't interfere with fiber. And the other thing is, it gives you that optical isolation from any surges or earth potential rises. So fiber, honestly, is a worthwhile investment, and you see it everywhere used today. It's very easy to terminate, considerably easier than 10 years ago. The other little issues are if the throughput of the operator station drops off, what do you do there? That's often a issue. You may find that you've got a lot of noise and interference on your communication links, and that's causing a problem. Carol, how's my voice? Can everyone hear me still?
You're still coming.
Thanks very much, Carol. I'm on a rather iffy bandwidth here, but anyway. So just the last few comments before we close the session. One of the challenges is that a lot of the maintenance tasks are often outsourced to another supposedly professional provider of maintenance. The trick is to make sure that you actually have everything outsourced, where there's a comprehensive planned approach to maintenance, where you can actually check that the maintenance tasks are being done. And people often outsourcing, and that's causing problems. So in essence, with troubleshooting, a SCADA or a data acquisition system, there's a few things you need to look at, but as I said, one of the critical things is the communication infrastructure. Make sure that you're trying to use fiber where you can. Make sure you have good earthing philosophy for your racks. And then, as I said, one of the things which is often forgotten is maintenance and support for your I/O racks, input-output racks. You always think about the fact that you need redundant channels for communications. If one cable breaks, you've got another one. But also think of your I/O racks and think about power supply redundancy. In other words, you've got some critical input-outputs coming along, and then the power supply to the rack drops off. How will that impact on the overall system? So those are very, very important. So that's really all from me. Any questions or comments? Carol will send this out with the recording and everything. Any questions from you guys? Any comments? Any complaints? Otherwise, I just want to thank you very, very much for joining me for this session. Really, very much appreciated. Any comments, questions, please send them through to me. I'll give you my email address. So let me type it in there. steve.mccarthy@eit.edu.au. So let me check that's right. Yep. So if you have any questions, send them through to me, or any comments or any complaints, please send them through to me. Or indeed, you can send them through to Carol if you're not getting copies of the recording. So Carol, can you type your email address in there? Thanks very much. Otherwise, I hope you have a marvelous day, full of lots of exciting stuff with SCADA and troubleshooting systems. Thank you very, very much, guys, for joining me for this session, and we'll get the slides to you. Otherwise, hope you have a marvelous day wherever you are in the world. To log out, just go to the top right-hand corner. Carol will tell you how to log out. And thanks for joining us. Bye.